Just wanted to either review or introduce this, what we've been calling the biodiesel reaction, what we probably more accurately should be calling the transesterification reaction. So this is where we're essentially trying to break or cut off these lipid tails off of the glycerol backbone. Okay, but one thing we got to keep in mind is we don't really want this guy. So these little squiggles are my carbon tails. I'm just being lazy. We don't really want this. We don't want this fatty acid here for reasons that we can go into later. Instead, what we're going to do is we're going to cap this with another carbon. So we're going to take one ester linkage between this fatty acid or this lipid tail, and we're going to replace that ester linkage with a carbon. Okay, and this carbon comes from our alcohol. Okay, so the first part of this reaction is where we react our alcohol, our methanol, our one carbon alcohol with sodium hydroxide. Okay, so this sodium hydroxide, this base, will separate into a positively charged sodium ion and a negatively charged hydroxide ion. Okay, so this is our base, meaning that it really wants to, this guy really wants to react with a proton, a positively charged hydrogen ion, and if you add those two together, or those two get together or bond together, you get water. Okay, so that's what this base wants to do. It really wants to suck a proton out of somewhere in order to become water. All right, in this reaction, right, so the first step for making biodiesel is to react this methanol with the sodium hydroxide. When you have this hydroxide ion in with the methanol, the hydroxide will steal the hydrogen off of this alcohol. Okay, it'll come and steal that hydrogen, and then you're left with a negatively charged, what we call methoxide ion, and water. Okay, this is what we really want. That's what this catalyst, the sodium hydroxide, does. It makes methanol into this methoxide ion, and this is what's going to react with our triglyceride. Bear with me here for a minute. Oops. Sorry. So when we're ready to do this, we're going to take our triglyceride. For us, it's going to be the vegetable oil. And we're going to react it with our methoxide. Sorry for my ugly drawing here. All right, so, and we're going to react this with our methoxide. All right, and what happens is, oops, I did this incorrectly here. We're just here, our methoxide ion. So this is going to come in here, and even in organic chemistry, we actually use the word attack. It's going to come in here and attack this carbon here. And for a brief while, what you get is this. You get this reaction intermediate that's present for maybe a few thousandths or even millionths of a second. And what happens is you get this as a single bond with a negative charge, and you get this methoxide bonding to this carbon here for a second. Now, very quickly, this bond here breaks. We break this bond. And what we're left with is, when we're finished with this, we have this. We have our carbon with its tail, and it's capped with this methyl group. Okay, this is much more stable, again, than our free fatty acid. This piece here, this methyl ester of our lipid tail, this is our biodiesel. Okay, this is what we want. We also get out of this, we also get water, and we get glycerol. That is our polyalcohol. Okay, so we have to separate. In our first separation piece, we're separating this from our biodiesel. Okay, I hope that helps. Let me know if you have any questions.